let's see, today's schedule is first, me. I'm going to talk about computer development that happened here when this was an Army base. This whole place was built in like 1913 by Marconi. Fred will talk about that later. A month before Pearl Harbor, the US Army Singapore acquired this facility and made it into a radar and communications R&D lab. From that point until the mid-1990s, this was a working Army Singapore R&D lab. But it was secret. So we're just beginning to uncover what actually happened here inside the buildings. And my club, March, Mid-Atlantic Retro Computing Hobbyists, we got involved here in about 2005. But InfoAge had been underway as a museum since around the late 90s, getting started. And most of the people who founded InfoAge were antique radio club people, which is the exact same hobby we all have, just different names and numbers, technology. So they knew all about what happened here in terms of history of radio, Marconi, radar, etc. And they didn't know much about any computer developments at all that happened here, if any. So when March got involved a couple years ago, we started trying to uncover, see what happened here related to computers. And at first, we thought maybe we could just find out what computers were used here during the radar and radio research. We dug deeper and deeper, and we found out a lot of computer stuff actually happened here development-wise, and that really fascinated me. So I started researching that, and we came up with 9 or 10 bullet points of things that happened here. You guys all know about ENIAC, right? Anyone doesn't know about ENIAC? No? Good. Okay, I don't have to explain that. The common story about ENIAC was that it was built to compute trajectories for mortar rounds in World War II. That's what it says on the funding proposal that John Walkley wrote. That's what all the history books about ENIAC say. And it's a plausible story. Most of the history books were written in the 70s and 80s when this place was still a deep, dark secret. We found out a couple years ago that there's another side to the story. Walkley started as a physics professor at Penn in 1941. Didn't make a lot of money. Before that, he was a professor at Ursinus College outside Philadelphia. And this place opened just about 41. John Walkley was offered a job here as a scientist, as a physicist, and declined it because it didn't pay well enough. He held out for something better, got a job at the Moore School at Penn. That job didn't pay too well either, but Penn offered his professors freelance work to do other science. And the Moore School, well, Camp Evans here was a customer of the Moore School. We were one of the people giving them projects to do. And one of the projects we gave them in 1941 was a project to do the math for parabolic radar antennas for this place. And that project ended up being assigned to John Walkley. And I found an interview he gave that was kind of, somehow, nobody knew about it until later. It was interviewed in the 70s. It was kind of unknown until recently. In which he told the interviewer that every time he was doing the math for this Camp Evans radar antenna project, he came back to this idea he had. And around the late 30s or so, the idea for a digital computer was in the air. A lot of people had the idea. But it wasn't really plausible enough to build it. There was relays, and they just weren't advanced enough at the time. Vacuum tubes were ultra primitive. But Walkley was one of many people with the idea. And so he went to the Wharton School, the business school at Penn, gathered up all the mechanical anti-machines he could find to do the Camp Evans project aside from his teaching duties, and it just wasn't enough math power. So he went to his boss and said, hey, remember the idea of a digital computer? Now I've got a reason to build it. Get these crazy Camp Evans people off my back. And the boss said, good idea, but the Army will never fund it. Come up with something else. So that's when he realized the Army had other mathematical needs, such as computing trajectories for mortar rounds. So his boss said, okay, they'll probably fund that. So on the funding proposal, he says, the reason I want to build this computer is to compute trajectories for mortar rounds. The Army funded it. War ended before the computer was even finished. But the point is, the thing about the trajectories was just what he wrote to get the money to build the computer. And ever since history, through the 70s and 80s, computer history books, it says that's why he actually built the computer, but that's just not true. He explicitly said in the interview in the 70s that I found, he quite clearly said, what got me off my rear to stop thinking about a computer and actually start building it was the Fort Monmouth radar project. And whenever somebody says radar lab at Fort Monmouth in the 1940s, they mean Camp Evans. So we could say with a straight face that we had a role in the development of ENIAC. None of that changes computer history very much, but it's huge for us, third part museum. So that's something the history of books will not tell you. The Vacuum Tube Development Committee. In 1943 and 1945, once a month at the Empire State Building in New York, America's top 30 or 40 scientists and engineers met. Something called the Vacuum Tube Development Committee. And it was government, academic, military. Basically, they talked about ways to improve vacuum tubes, and they talked about ways to commercialize the technology. When vacuum tubes were done, they knew it would be a while before they caught on and were very affordable. So it was in the military's own best interest to make them commercialized and make them more reliable, production ready, bring the cost down. Harold Zoll, who was basically the CTO here at Camp Evans, was a key member of that committee. So it's another thing related to computer development that Camp Evans had a role in. And I've actually seen the invitations and the meeting agendas, and it says Harold Zoll, Camp Evans scientist. He's on there. You guys know about Electronic Associates? Anybody? Electronic Associates, EAI, was an analog computing company based here in Monmouth County, a couple towns down the road. And a man named Arthur Adamson and Lloyd Christensen founded that company. And they were alumni scientists and engineers here at Camp Evans. So, also, once it became clear, I guess in the 60s or so, that analog computing was heading toward obsolescence, people from Electronic Associates spun out another company, which was Interdata, which became PerkinElmer and Concurrent Computer. And they were a popular mini-computer company competing against DEC, one of the first mini-computer companies to do a 32-bit system. So Electronic Associates came out of Camp Evans people, and Interdata came out of there. So that's, again, more connections we have to the history of modern computing here at Camp Evans. And let's see here. Back to the University of Pennsylvania. This isn't really related to development. I just find it interesting. Fred, the museum director, found a contract that says on it that we were a customer of the Differential Analyzer at the University of Pennsylvania in the late 40s. And it has some Army lingo on a contract, which indicates here. It says ESL, which means Evans Signal Lab. That's the Army lingo for this place. So we got to use a differential analyzer, and we have a picture in one of the exhibits back there of some women, who were the first programmers, using a differential analyzer, one of which was Kay Mauchly, John Mauchly's husband. And we know it's her in the picture because last year our keynote speaker was Bill Mauchly, his son. He said, yeah, that's my mom. So you all know about Bell Labs and a transistor, obviously. When Bell Labs announced their transistor, before they put it in the media, they brought together all the top scientists and everything, and they said, we have this amazing new thing, transistor. And everybody in the room, all the government scientists said, whoa, we have to make this top secret right now. We can't have the enemy get hold of this. It has to be declared a secret technology. And again, Harold Zoll, I mentioned earlier, Camp Evans fought tooth and nail to make it public. And there's a book called Crystal Fire, which I highly recommend, about the invention of a transistor. And there's a whole chapter in there about how Harold Zoll at Camp Evans fought to make the transistor public. He won that fight, and you guys know what became of transistors. So thanks to Harold Zoll, I mean, transistors, chips today might be 10, 15 years back if it wasn't for him pushing to make it public and commercially available. So you could thank Camp Evans for that. Okay, 1953, MIT and IBM sent scientists to Camp Evans to learn about the latest technologies in cathode ray tubes, video technology. There was a computer at MIT called Rawlin, and it was supposed to be a Rawlin 2, which I think was probably one of the first computers to even use video technology. Rawlin 2 was never completed and never built. But they took video technology being developed here at Camp Evans, brought it back to IBM and MIT, and Rawlin 2 became SAGE, the semi-automatic ground environment defense system. And so that took video technology from Camp Evans. So we had a big role in using user interface for SAGE. And moving right along. Moby Dick. How many of you were here last year to hear the lecture about Moby Dick and field data? Okay, good, I can tell it again. In the mid-50s to early 60s, this place was a hotbed of research, and including computers. And there was a computer they built here called Moby Dick. It was designed here, and then the assembly and engineering was subcontracted to Sylvania, Massachusetts. But the design happened here at Camp Evans. Moby Dick was mobile digital computer. And mobile in 1956 meant it was so small, it fit into an 18-wheeler. 1956, mind you. And of course, the inside joke was Moby Dick, big as a whale. Anyway, the Army supplied a 30-foot trailer, and they built the computer, designed it here, built it in Massachusetts, drove it down to Aberdeen Proving Ground in Maryland. Now, last year, one of our speakers was the guy Camp Evans, who designed Moby Dick. And he said they took it to the Aberdeen Proving Ground, and the computer worked great, and the Army truck broke down. I like that story. Out of Moby Dick came something called field data. Field, and just one D, field data. Field data became something called ASCII code. So that's a direct route from Camp Evans' work, modern ASCII code. Moby Dick was actually the second computer developed in a trailer. First one was built by the National Bureau of Standards a few years prior. But Moby Dick, they built about 7 Moby Dick computers. And it was the first computer that could share data with other computers. Now, I've yet to I'm trying to find a good history of networking. If you go on Wikipedia or Google, all you hear, they start with the ARPANET, and they start with Xerox in the 70s. I want to know about computer networking in the 50s and 60s. I'll put it out there as a possibility that 2 computers sharing data, that's a network. I've never seen anybody say anything earlier than 1956 before, so it could well have been the first computer network. I'm not claiming it is, but it's a distinct possibility that it happened here. And I just find that absolutely fascinating. Also, whereas the previous computer a few years earlier for National Bureau of Standards, that computer was also in a tractor trailer. It was sent to the White Sands Missile Base, and the white sand got in it and didn't really work. Moby Dick, they actually made a half dozen of them, sent them to Europe, and actually used them. So one could argue that if you consider the fact that it was designed to be mobile, a portable computer, now obviously it's not portable as we think, but it was designed to be moved, therefore portable. And the sense that the previous one didn't work a few years earlier. So you could say that this was the first functional portable computer. And you could say it was the first computer to be a network. And we know for a fact it happened here at Camp Evans. And no computer history book is going to tell you that, because it's all just now being uncovered. So I could say, yeah, we had the first network and the first portable computer here at Camp Evans, and I wouldn't really be lying. We need a little more documentary proof, but it's the top level. It was also one of the first transistorized computers, by the way, but there's a half dozen people, including RCA yesterday here, who all claimed to have probably the first transistor computer, so we got to sort that out and figure out what happened and when it happened. Also in 1956, IBM had its first scientific computing seminar here. And about the same time, IBM formed SHARE, which was their user group. And it was those groups that formed the concept of giving away software. Just like with the Moby Dick thing, we're not going to say open source started here, because that would just be ridiculous. But IBM did have its first user group meeting here. From that group came the idea of giving away software and charging for the hardware. So you could draw conclusions if you wish. Anybody ever heard of MicroModule? No? Okay. 1957, actually 1953, it was starting to become clear already in UNIVAC and stuff, but there was a problem, a monolithic problem, that transistors make heat, and there were too many, and the things were too big and heavy. They needed a smaller technology. Transistors, they could tell already, were going to have a big problem as computers got bigger and better. In 1953, the Navy, I don't even know where this happened, but the Navy had something called Project Tinkertoy. And the idea was to take groups of components, a transistor component, a diode component, a capacitor component, group them together in a single module, like a Lego block, and make not integrated circuits, but modular components. Didn't really help with the size any, but it would make things quicker and easier to assemble at the least, and cheaper. Project Tinkertoy was a failure, didn't go anywhere. In '57, the Army picked up the same idea, and they called it MicroModule. And the primary location for MicroModule was up in Fort Monmouth down the road. A MicroModule was about the size of a sugar cube, and it contained various components. So you could have like a transistor diode MicroModule, a capacitor transistor module, etc. And they all plugged together like Lego bricks. And RCA was the key contractor in that project. And about 20 companies and military bases and universities around the country were all involved in MicroModule. Camp Evans was a key testing lab for MicroModule. After they perfected MicroModule, they said, let's build a sample application. So here they built one of the first, if not the first, walkie-talkie using that technology as well, and that happened here. They also built something called MicroPack, which was essentially a mini computer in 1960, 5 years before DEC invented the mini computer. It was a 90-pound transistorized mini computer 5 years before DEC said they invented it, before the PDP-8 we have on display. So we were a key testing lab for that technology. And finally, because Camp Evans was such an important R&D lab for the military, especially from the 40s to the 70s and 80s, a lot of important people in computer history passed through here at various points in their career. And I'll give you kind of highlights of those. Fred Terman, the Dean of Stanford Engineering, and he also ran the Harvard Radio Research Lab. He's considered the father of Silicon Valley, depending on who you ask. When this place opened in the early 40s, they said, okay, we need to get the nation's best scientists. How are we going to get them? Somebody said, let's call Fred Terman. He was the father of Silicon Valley. So Fred Terman personally picked his best and brightest and sent them out here. One of the little startups, hot little startup in California in the 40s was, 30s actually, was Hewlett Packard, of course. And Bill Hewlett was assigned to the military before World War II started. And he was sent to go some lab somewhere that was making better bullets and bombs. And one of the early customers that Hewlett Packard called on in the 30s was Fort Monmouth. He didn't get the contract, but he made good contacts. And so when he was assigned to go work on bullets and bombs, he said, wait a minute, I'm the nation's hottest young electrical engineer. It's wasting my time to send me working on bullets and bombs. So we called his Fort Monmouth people, who by then were at Camp Evans, and said, get me out of this. This is a waste of my time. So they had them, they had Bill Hewlett assigned as an essential employee and sent him back to Hewlett Packard to do your thing. A couple months later, the war broke out, and they said, I'm sorry, Bill Hewlett, we need you back. This time, he was sent to Fort Monmouth in Washington as well. And during that time, many times he passed through Camp Evans. So we know Bill Hewlett was working in and around Camp Evans at various points during World War II. While he was here in the summer of 1941, he met a guy named Howard Boehm, who was a young graduate. And Howard Boehm said, wow, I hear you guys have the hottest young startup in California. Hewlett Packard was maybe 20 employees at the time. Can I come work for you, Mr. Hewlett? And Hewlett said, you could, but these days you're better off doing a startup. It was not like the 90s. And Boehm said, okay. And basically Hewlett taught Boehm how to work in great space and do your own thing. So Boehm and his buddy formed a little company called Tektronix. Okay, and of course we all know Tektronix, the oscilloscope giant. So we have all sorts of documented history about what Howard Boehm did here and what inspired him to develop oscilloscopes and go for Tektronix. So he worked here. So whereas Hewlett passed through many times, Boehm actually was stationed here. Jay Forrester at MIT, guy who perfected core memory. Again, was one of the people who didn't work here, but a few months ago I took a trip up to Boston. I looked in the Harvard lab and the MIT archives, and we found all sorts of documents and memos, the kind of stuff you do by email today. Not huge developments, but ordinary doing business. And on all these projects that Jay Forrester worked on, including core memory, there was a list of 10 people who were CC'd, and it was always Camp Evans guys were on his list. So we were one of the organizations he was consulting with as he was developing these great technologies up at MIT, including core memory. Kurt Lahovic. Very few people, except for you, may have heard of Kurt Lahovic. Kurt Lahovic was here. I forget what year exactly. I guess in the late 40s, early 50s. And he worked on LED technology here. He had many pioneering papers in LED. And a few years later, he was one of the key pioneers of p-n junction isolation. Noyce and Kilby, the guys at TI and Fairchild who did integrated circuits, both independently in their own research, both cited Kurt Lahovic as like a key guy whose research they based, helped theirs do integrated circuits. So that's kind of the top 10 list, 50,000 foot level of computer developments that happened here at Camp Evans, or that Camp Evans was a big part of working on. And we're always uncovering more. And when we go to Harvard and do research, it costs money and there's resources, so we need all the help we can get. Anybody who knows somebody who might have worked here at Camp Evans in computers, we'd like to talk to them, please think of us. And so in the museum, we have a whole exhibit elaborating on all these points. And are there any questions? Yes, sir. InfoAge is open every Sunday, 1 to 4. Yes. No, but we are open by appointment as well for tours. Are there any questions about what I just talked about? Jeff?
You had mentioned that you were just uncovering information about Moby Dick. Where did you get that information?
Oh, okay. Well, the stuff about Moby Dick is not the stuff that I personally discovered. In 1987, I mean, you can Google Moby Dick, and there's all kinds of stuff out there about it. In 1987, a man named Watts Humphrey, who was one of last year's speakers here, wrote a paper for the IEEE Annals of the History of Computing. And he talked about everything he ever wanted to know about Moby Dick. And he said, Evans Signal Lab. It's not something we abstracted or it's something he's actually said. And he wrote the paper in 87. Here's a history of Moby Dick. And he wrote it, and everyone said, okay, that's interesting. And then it was just kind of forgotten about. No historians have ever studied it in any further detail. So last year, about this time, when I started realizing computer stuff happened here, I Googled Camp Evans computer development when I discovered that paper he wrote. And I said, wow, I've got to get that guy here. But I also realized, I found a bio of him, and apparently back in 87, he was older than dirt itself. And I said, I don't know how I'm going to find this guy. I called the company he worked at in 87. They said, oh, yeah, he's sitting in the next cubicle. Okay. Is he just a corpse there? Or So when he came here last year and gave a speech, and I think you were there, Jeff, right?
I was there Sunday.
Okay. So, and we have it on video, and we're selling pre-orders of a DVD next door. You can watch it. Any other questions? Yes, sir. Barry.
Have you put the conclusions and the discoveries that you made about the origin of EDIAC online to start the process of correcting mistakes in the textbook?
Yes. It's not on any big public website, but there are a couple of forums and mailing lists that are for computer historians. There's two kinds of computer historians, right? There's folks like us who were there and we know the nuts and bolts. And there's a whole other planet out there of PhDs and college professors who were academic computer historians. And they think we're a bunch of just amateurs. And it makes it hard. I'm in their role too. And last year I went to a conference, or 2 years ago I went to a conference of those people, all the PhDs and professors, and I went as an outsider. And they explained to me that they see us the way military historians see Civil War reenactors. They see us as trivia. That all we're good for is knowing which bit to flip on and out there. We're trivia to them, okay? But I gave a talk a couple years ago at some academic computer history conference, and I said, you know what? You guys need us, because they're 20 years behind in terms of what they're studying. They haven't gotten to S100 yet. They're still studying Univac, okay? And they're running out of things to write about. And the next thing they're going to study is mini computers and microcomputers. And when they get to that, they're going to need to talk to the users, regular people like us. So I gave a talk there about what you academic PhD types can learn from us and what we can learn from them. There's a lot we can learn from them as well. So that's the answer is yes, it is online, but so far it's limited to history discussion circles. It is not out in the big wide public yet.
Harvard archives, display case
Yeah, good enough.
there is a 6800 microprocessor that's distributed design.
I'm speechless.
Says Motorola got the back link right on the
You know, but another thing they have at Harvard though
That
is
might be the only one though that was ever made.
Yeah. But, you know-
Museum in Washington D.C. where they had an information technology display. And one thing they had was a Commodore 64 there, which apparently had a 808 CPU.
another thing they have at Harvard is they have the Mark I computer, which was built. I forget the exact timing. I think maybe a year or two before ENIAC. Claude, do you remember that? The Mark I, the Harvard Mark I, late 30s. That sounds about right.
It was finished just at the end of World War II.
Okay, and that was sort of like an electromechanical kind of computer, but they have it there, and you can go and see it, and so that's kind of cool as well. Any other questions? No. Okay, so that's what we know so far about the history of computing at Camp Evans.